Welcome to this explainer. Today, we're diving straight into a massive challenge in modern software engineering, and we're going to map out exactly how to build a modern, cost-effective Kubernetes observability pipeline. Whether you're an SRE, a DevOps engineer, or a developer, mastering this pipeline is literally a game changer for how you understand your systems. So I want you to picture this. You've got a massive Kubernetes cluster, dozens of nodes, hundreds of pods, thousands of microservices just constantly talking to each other. Suddenly, latency spikes, errors start rolling in. How do you find that single failing request hidden in all that chaos? Well, in a distributed system, traditional monitoring leaves you with these massive blind spots. You get this fragmented view. Logs are over in one system, metrics are in another, and traces, well, if you even have them, they're completely disconnected. It's kind of like trying to solve a giant puzzle, but all the pieces are scattered in different rooms. But getting this right isn't just about reducing your own on-call headaches, it's about massive business impact. By moving away from legacy, fragmented systems and adopting the open-source observability stack we're about to explore, companies are seeing absolutely incredible savings. Just to put that into perspective, Paytm Insider reduced their logging and monitoring costs by 75% using this exact architecture. 75%. That's not just a marginal tweak, that is a fundamental shift in how resources are allocated. Okay, let's dive into this. Here's our roadmap for today. 1. Taming Kubernetes chaos. 2. The open telemetry solution. 3. Low-code auto-instrumentation. 4. Routing with OTel collectors. And 5. Visualizing the full picture. Let's start with part 1, Taming Kubernetes chaos, where we look at unifying observability. Historically, if you wanted deep observability, you paid a serious premium for proprietary tools, which, inevitably led to vendor lock-in. Your data was basically trapped. But today, the industry standard has completely shifted. We're looking at a unified open-source stack that scales all the way from local development up to enterprise-grade clusters. This stack pairs OpenTelemetry with highly specialized backends, Prometheus for metrics, Loki for logs, Tempo for traces, and Grafana to tie the whole shebang together visually. This setup gives you complete control over your telemetry data without that massive enterprise price tag. Moving right along to part 2, the OpenTelemetry solution, our observability engine. So the crucial point is this. OpenTelemetry, or OTel, is not a storage backend. It doesn't visualize your data at all. It's a vendor-neutral framework designed purely to generate, collect, and export your telemetry data, so your traces, metrics, and logs. It extracts the data from your applications and infrastructure, but it doesn't dictate where that data has to live. This means you can literally swap out your storage backend later without having to rewrite a single line of instrumentation code in your apps. Huge time saver. To truly understand this, I want you to build a mental model of the telemetry journey. Think of it as a 4-part pipeline. First, we extract data from the application. Next, we route that data using an intermediary hub. Then, we store the data in highly specialized databases. And finally, we visualize it for human analysis. Keep this mental model in mind because we're going to walk through each of these steps practically, starting with the extraction phase. Which brings us to part 3. Low-code auto-instrumentation, extracting without the hassle. Now, if you have dozens of microservices written in Java, Python, Node.js, Go, manually instrumenting all that code would literally take months. Instead, we use the OpenTelemetry operator for Kubernetes. It's this beautifully simple 3-step process. First, you install the operator into your cluster using a Helm chart. Second, you add a single line of metadata, just an annotation, to your application's Kubernetes deployment file. And third, the operator just takes over. It watches for new pods being created, reads that annotation, and automatically injects the necessary instrumentation agents right into the pod the second it starts. Notice that single string of metadata right there. With just this true statement, the operator intercepts the pod admission request. It sideloads the OpenTelemetry Node.js modules straight into the container, hooking right into the application start. It gathers rich trace data, metrics, context, all without your developers having to modify a single line of their actual business logic. It's honestly incredibly powerful. All right, on to part 4, routing with OTel collectors. Let's see how we move all this telemetry around. So all that extracted data is pushed to the OpenTelemetry collector. Think of the collector as a highly efficient centralized post office. It operates on a pipeline model. First, receivers ingest the data, whether that's OTLP data pushed directly from your apps or metrics pulled from your Kubernetes nodes. Next, processors handle the packages. They might batch the data, filter out sensitive info, or enrich the telemetry with Kubernetes metadata, like pod names and namespaces. Finally,
exporters deliver the packages, translating the data into the specific formats required by your chosen storage backends.
Now, what's really interesting about this is how we deploy these in a Kubernetes environment. The collector is highly modular, and teams typically use a two-tier architecture combining two different modes. First, you run collectors as a daemon set, meaning one instance runs on every single node. This is absolutely perfect for scraping heavy node-local data like host metrics and container logs with extremely low latency. Then, those daemon set agents forward their data to a centralized gateway deployment. This gateway aggregates everything, scales dynamically, and acts as the single exit point pushing data out to your storage backends. This layered approach is a lifesaver because it prevents data duplication and completely optimizes your network traffic.
Finally, part 5, visualizing the full picture.
So to avoid those bloated, super expensive monolithic databases, we route our signals to highly specialized backends. We send our time series metrics to Prometheus, we send our logs to Loki, and we send our distributed traces to Grafana Tempo. Now, what makes Tempo so brilliant is that it's an index-free tracing backend. Unlike older systems that require really expensive indexing databases like Elasticsearch, Tempo relies entirely on trace IDs for lookups. This allows it to use dirt-cheap object storage like S3. Then, sitting on top of all three of these databases, we have Grafana acting as our single pane of glass for visualization. But, just having the data in these backends isn't really enough. The true climax of this explainer, the absolute peak of modern observability, is how we tie them all together. And that is done using a sort of magic trick called exemplars. And this brilliantly illustrates why this entire OpenTelemetry architecture is worth the effort in the first place. An exemplar is essentially a trace ID attached directly to a metric sample. Because we used OpenTelemetry to inject a consistent trace ID across our entire system, Grafana can do something amazing. When you're looking at a Prometheus dashboard and you see a massive spike in API latency, you don't have to guess what caused it. You literally click on the spike in the graph, and Grafana uses the exemplar to instantly query Tempo, pulling up the exact distributed trace of the request that caused that specific latency spike. It bridges aggregated metrics instantly to highly detailed traces, totally slashing your troubleshooting time.
So, I leave you with this question to ponder. Is your cluster truly observable, or are you just collecting noise? By utilizing OpenTelemetry to extract standard data, collectors to intelligently route it, and specialized backends linked by exemplars, you transform raw data into instant answers. Think about your current setup and consider how applying this mental model could bring order to your own Kubernetes chaos. Thanks for joining me on this explainer, and keep learning.